Hello everybody, my name is Miloš Milošević. I'm coming from Belgrade, from Serbia, from Innovation Center of Faculty of Mechanical Engineering. And this multidisciplinary research is done with my colleagues from Faculty of Dentistry and from Faculty of Mechanical Engineering, as well from Belgrade. This subject is very common with the team from last presentation from Rosalia, and dental implants have huge, or implementing dental implants in dentistry have huge problems, such as positioning of dental implants in different zones. So our task from our colleagues from Faculty of Dentistry was to develop procedures and to calculate strains in blocks in different positions of implant that are vertically loaded. And in next stage, our another task is to develop procedure for testing different types and geometry of implants. So usually we use contact and non-contact measurements for strain analysis, such as strain gauges or extensometers. And for this research we use the non-contact optical material independent method known as digital image coloration method for determining of strain in on different surfaces of block. So this, as I said, the method is material independent, and we use it for different kind of analysis, such as the analysis of strain field on key implants, and for determining fracture or mechanical and fracture properties, and for analyzing objects with complex geometries, such as, for example, block valve housing, where in some complex zone is difficult to measure strains in all three dimensions and displacements as well. Also for analyzing of stress and strain in tooth fillers that produce stresses during the shrinkage. This shrinkage is also for the same department of Faculty of Dentistry was tasked to develop methodology to calculate shrinkage of dental composites that produce, during the polymerization, they produce micro cracks, marginal discoloration, or post-operativity sensitivity. So we develop procedures to calculate these strains or shrinkage during the polymerization of these materials, and as well stresses that shrinkage produce, and calculate movement of opposite cavities walls in tooths, and using final element method verify this model and calculate stresses for different composite materials. So in this research, this is early beginning of our research on this field. So our task was to develop procedure to calculate strains in two different surfaces for vertically loaded tooth implant by using digital image correlation system. So one surface is are 2 millimeters displaced from tooth implant, and another surface is 4 millimeters. So before measurement, we need to apply thin white layer of white color, and then black speckles to get this stochastic pattern to calculate strain. Digital image correlation system recognizes these speckles and gives them coordinates in all 3 dimensions, and during the loading we calculate strain in some specific zones. So the force or loading was applied axially by 50 newtons increase to the 500 newtons maximum, and here are shown visualization of strain field in X and Y direction for both surfaces. And after that, using this system, we calculate increase of strain during the loading. Then another task was to show the strain values in a direction of implant in the central zone or in the direction of loading. So the diagram of section length and Mises strain was then made just to get visualization of influence of different positioning of implant in block. Block was made, I didn't say that, from polymethyl methacrylate material that sometimes is used like bone substitute, and it is easier to get the same experimental conditions for different types of dental implants. And in this paper we developed, as I say, procedure and experimental setup for determination of strain in different position, just to have, let's say, procedure to compare different implant geometries in the same conditions. And our future research was also to rotate the position of implant in the same block, and as well to do calculation by using final element method. Thank you very much.